All right, let's get right into it. We hear about hydrogen all the time, right? It's pitched as this key player in our clean energy future. But what's the real story here? Is it really the silver bullet we've all been waiting for?
To really get why this conversation matters so much, you have to start with this number, 21.3 billion tons. That is the insane amount of carbon dioxide we pump into the atmosphere every single year just from burning fossil fuels. It really puts the scale of the problem we're facing into perspective.
I mean, let's be honest, our entire world runs on fossil fuels. They've powered everything for centuries. But here's the catch. They're also the #1 driver of climate change, and that's a challenge we absolutely have to solve.
And just look at how dependent we are, nearly 90%. Think about that. Almost all the energy that makes, well, everything, our cars, our phones, you name it, comes from these carbon-heavy sources. So getting off this stuff isn't just a minor tweak. It is a massive, massive undertaking.
So if fossil fuels are the big problem, could hydrogen be the solution? On paper, this stuff looks like a superhero. It's the most common element in the entire universe. And wow, it packs a serious energy punch. Let's break down how it's supposed to work.
Okay, first things first, and this is super important. Hydrogen isn't really an energy source. It's what we call an energy carrier. The best way to think about it is like a rechargeable battery. You use a real source, like a solar panel, to charge up the hydrogen, and then you can store that energy and use it whenever and wherever you want.
So here's the dream scenario, right? The perfect clean cycle. You start with clean electricity, maybe from a wind farm. You use that power to split water, yep, good old H2O, into hydrogen and oxygen. Then you can store that hydrogen, move it around, and whenever you need power, you let it recombine with oxygen. And what do you get? A whole lot of energy and, get this, the only byproduct is water. Just water. That's a perfect loop.
And this slide, right here, this is the whole ballgame. On the left, you burn fossil fuels. You get energy, sure, but you also get CO2 that warms the planet. On the right, you use hydrogen. You get energy, and the only other thing you get is clean water. No carbon, no pollution. It's just so clean. It's an unbelievably elegant idea. But, and you knew there was a but coming, right? It all sounds a little too good to be true. And that's because that perfect clean loop we just talked about, that's the dream, not the reality of today. The hydrogen we're using right now has a pretty big, dirty secret.
Which, begs the question. If we're not using all those wind turbines and solar panels to make it, where on earth is all this hydrogen actually coming from?
And boom, here is the reality check. A whopping 99% of all hydrogen is made from fossil fuels. 76% from natural gas, another 23% from coal. The process basically uses steam to rip hydrogen out of methane, and yeah, it creates a ton of CO2. So we're using a dirty process to make a supposedly clean fuel. Kind of defeats the purpose, doesn't it? So that means only 1%, just a tiny, tiny fraction, is the green hydrogen we've been dreaming about, the kind made with renewable energy. The other 99%, we call that gray or brown hydrogen, and it comes with a seriously heavy carbon footprint.
So, if we want to get from that measly 1% to a real hydrogen economy, well, we've got some massive mountains to climb. It is not just a matter of flipping a switch.
It really all comes down to three big things. First, the cost. It's just way too expensive right now. Second, logistics. How do we store and move this stuff safely and efficiently? And third, scale. We just don't have the technology ready to do all this for the entire planet. Yet.
And the money problem is a huge deal. Just look at these numbers. Making gray hydrogen from natural gas costs maybe $2 a kilogram. But the clean, green stuff, we're talking anywhere from $4 to $8. That's more than double, easy. And in our world, economics is king. This is probably the single biggest barrier.
But hold on, it's not all doom and gloom. Far from it. Because even with all these challenges, governments and companies all over the world are placing a huge bet, a truly massive bet, that we can solve these problems.
And you can see that bet right here in the spending. Public investment in hydrogen research has absolutely skyrocketed, hitting an all-time high in 2022. This money is laser-focused on crushing those cost and scale problems we were just talking about. And this isn't just about research in a lab somewhere. We are talking about gigantic, real-world projects worth billions of dollars. I mean, look at this, an $11 billion project in Chile. Massive hubs popping up in Spain, the US, Portugal. This is a serious global push.
So why? Why throw all this money at it? What's the potential payoff? Well, get this. The thinking is that if we pull this off,
hydrogen could power almost a fifth of our entire world's energy needs by 2050. That would be a game changer for decarbonizing things like heavy industry and global shipping.
Which brings us right back to where we started. On one hand, you have this incredible revolutionary potential. On the other, you've got a really dirty secret and some enormous hurdles to overcome. With billions of dollars on the line, the question isn't just if we can unlock a hydrogen future, but what kind of future it's going to be. A truly green revolution or just a very, very expensive detour? The answer is going to define our energy landscape for generations to come.